Jai Hind students, how are you? All good? Okay. Students, I have explained to you in my last video about the polynomials, types of polynomials, degree of polynomial and zeros of polynomial. So, today we will discuss about how to find zeros of given polynomials. So today I am going to start our very first exercise of this chapter, polynomial, exercise 2.1 of grade 10th. So this is exercise 2.1. Here only one question is there. The question is the graphs y is equal to p of x are given below for some polynomials px. Find the number of zeros of px in each case. Students, here the graphs of some polynomials are given and we have to find out how many zeros are there. Understood? So here some graphs are given and we have to find out the number of zeros of that polynomial. So beta, how can we find out the number of zeros by the graph of polynomial? So listen very carefully. Here the graph is y is equal to p of x. Here the polynomial is of x. So some graphs are given. We have to identify how many zeros will be there. So the number of zeros will also equal to, are you getting what I am going to say? Beta, number of zeros are always equal to number of those points where the graph of polynomial intersects the x-axis. Understood? The number of zeros of polynomial are always equal to those points where the graph intersects the x-axis. See, in this graph, there is a straight line which is parallel to x-axis. You know x-axis and y-axis? The horizontal line is known as x-axis and the vertical line is known as y-axis. So you can see here, this line is represented as the graph of y is equal to p of x. So this line is parallel to x-axis and we know that parallel lines never intersect each other. You know, parallel lines never intersect each other. So these two lines are parallel, so they will never intersect. That means there is no intersection point of this line and x-axis. Understood? So this graph will never intersect the x-axis. That means this polynomial has no zero. Understood? So what is the answer for that? Px has no zeros because it does not intersect the x-axis. Got it? Now, see the second graph. See this graph. Here, this graph intersect x-axis at only one point. That point is this. Are you getting this? This graph intersect x-axis at how many points? Only one point. So if there is only one intersection point, that means the number of zeros will be 1. Means the zeros of this polynomial has 1 zero because it intersects x-axis at one point only. Got it? So we can write here px has 1 0 because it intersects the x-axis at one point. Clear? Now see the third graph. Here the graph is this, in a shape of U. Are you getting this? So this U intersect x-axis at how many points? It intersect x-axis at 2 points. One point is this and second point is this. So this graph intersects the x-axis at 2 points. So it has how many zeros? 2 zeros, means number of zeros is always equal to the number of intersection point. So we have to write here Px has 2 zeros because it intersects the x-axis at 2 points. Is it clear? Now, the third graph. See here. The graph is just like a wave. So it intersects x-axis at how many points? We will count here. One intersection point, second intersection point, and this is the third intersection point. So how many intersection points are here? 1, 2 and 3. So if intersection points are 3, so the number of zeros will be 3. Reason? Because the graph of Px intersects the x-axis at 3 points. So it has 3 zeros. So you have to write here Px has 3 zeros because it intersects the x-axis at 3 points. Is it clear? Simple. And here our very first exercise has finished. Are you getting this? Again I am telling you, by the graph we can find out the number of zeros of the polynomial. How can we find? The number of zeros of a polynomial is always equal to the number of points of intersection at x-axis. The graph intersects x-axis. We have to find the number of intersection point where the graph intersects the x-axis, and the number of intersection point will always be equal to the number of zeros. So by this concept you can solve this whole exercise. Understood? Hope you are getting. Now this is our exercise number 1. Now students, let's start our second exercise of polynomial, that is exercise 2.2. Here the very first question is, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and coefficient. But in the very first question, some quadratic polynomials are given. You know what are the quadratic polynomial? A polynomial whose degree is 2. A polynomial whose degree is 2 are known as quadratic polynomial. So in this exercise, we will find out the zeros of a quadratic polynomial, and after that we will verify the relationship between the zeros and the coefficients. So some quadratic polynomials are given here. I am taking 3 examples. 6x square minus 7x minus 3. This is first example. Second is x square plus 8x plus 15. And the third example is x square minus 17. So first we have to find the zeros of quadratic polynomial. So I am taking the first example. So solution of this. First of all, we will consider the given polynomial as p of x. Here, this polynomial, in this polynomial, what is the variable? Variable is x. So we will consider this is a polynomial of x. So we will consider p of x. Let p of x equal to whatever is given here, 6x square minus 7x or minus 3. So beta, this is a quadratic polynomial and it is having how many terms? 3 terms. First term is 6x square, second term is minus 7x, and third term is minus 3. So how can we find the zeros of this polynomial? So we will use here, we will factorize this polynomial, and the method for factorizing the quadratic polynomial is known as splitting the middle term. So here, what is the middle term here? That is minus 7x. This is the middle term. So the name of the method is splitting the middle term. Means we will split the middle term. So, but how can we split the middle term? So the very first step is we will multiply the constant term by the coefficient of x square. Please note this point. The very first step is we will multiply the constant term by the coefficient of x square. So beta, what is constant term here? That is 3. So this 3 is multiplied by the coefficient of x square. So what is the coefficient of x square here? That is 6. So 3 into 6. We will get how much? 3 6 are 18. Understood? We can multiply constant term and the coefficient of x square. So 3 into 6 we will get 18. Now we will break 18 into 2 factors. We will break 18 into 2 factors whose sum or difference. Where we have to take the sum or where we have to take the difference. It depends on the sign of constant. This sign. This is a constant term and it is its sign. If this sign is negative, so then we will have to take the subtraction sign here, or if it is plus, then we will have to taking the sign of plus. So which sign is here? That is minus. So I will put here minus. So now we will break 18 into 2 factors so that their subtraction, minus is here now, so their subtraction will gives you the coefficient of middle term. What is the coefficient of middle term? That is 7. Are you getting this? First we will have to multiply the constant term by the coefficient of x square. So 3 into 6 we will get 18. Now we will take the sign of constant. Constant is 3, its sign is minus. If minus is here, then we will have to put minus here, or if this is plus, then we will have to use plus sign here. Now the factors of 18 whose subtraction gives you the middle term. Middle term is 7. So what will be the factors of 18 whose difference gives you 7? Can you tell me the factors of 18 whose subtraction gives you 7? So these factors will be 9 and 2. Just check. 9 and 2. Both are the factors of 18. And the multiplication of 9 and 2. 9 2s are 18. And the difference 9 minus 2. You will get 7 or not? Am I right? So we will get the numbers 9 and 2. So in the next step, first term will remain same, 6x square. The name of the method is splitting the middle term. We will split the middle term. Minus sign will be here. Now this 7. In place of 7, we can write 9 minus 2. 9 minus 2, we can put in place of 7. So 9 minus 2 into x or minus 3. Got it? Now, in the third step, we will multiply x inside the bracket. So this 6x square minus 9 into x. So it will be minus 9x. Now 2 and x. 2 is multiplied by x. So it will be 2x. And this minus is here. So minus into minus. It will be plus. Because minus is here. So minus into minus gives you plus. And minus 3. It will remain same. Understood? Okay. Now there are 4 terms. One term, second term, third term and fourth term. Now we have to take something common from first two terms and taking something common from last two terms. So what we have to do now? We have to take something common from first two term and from last two terms. So tell me, what is common in these two terms? 6x square minus 9x. So 6 and 9, both numbers will come in a table of 3 or not? Yes. So 3 can be common because 3 is a factor of 6 and 9 both. Now this is x square and this is x. I told you, you know very well, okay, if same variables are here, then the lowest power we can take common. So x is here, this is x square, so x will be common. So what is left? In a table of 3, 6 will come at which place? 3 2s are 6, so 2 is left. X square is here, x is common. So what is left inside? X is left. Minus 3x is common, 9x is here, x is out, 9. In place of 3, 9 will come at which place? 3's are. So if we take 3x common from these two terms, then what is left inside the bracket? 2x minus 3. Is it clear to everyone? Okay. Now this sign plus will remain same. Now what is common in these two terms? This is 2x and this is minus 3. So here nothing is common. Or if nothing is common, then we have to take 1 as common. Note this point in your mind. If nothing is common, then what can be common? 1. We will take 1 as common. Or if 1 is common, then there will be no effect in both the terms. It will remain same. That is 2x or minus 3. This step is clear to everyone? Okay. Now see. In this step, we are getting two brackets. And just see these brackets. Inside the bracket there is 2x minus 3. Or here this is also 2x minus 3. Means these two brackets both are same. So in every question these two brackets will be same. Again this point you have to note. In this, at this step, in every sum these two brackets will be same. Now if these two brackets are same, so take these brackets as common. So I am taking 2x minus 3 common. So what is left? This is common. So what is left from here? That is 3x. And this is common from here. So what is left from here? Plus 1. So at last we will get 2x minus 3 and 3x plus 1. Now our splitting the middle term method is completed. But question is not asking to factorize this polynomial. Question is asking find the zeros of this polynomial. After doing this, we will have to write hence for finding the zeros, we have to put p of x is equal to 0. If we want to find zeros, then we have to put p of x is equal to 0. But p of x is equal to 2x minus 3 and 3x plus 1. So in place of px, we can put these values. So 2x minus 3 and 3x plus 1 equal to 0. Now see, here the product of these two brackets is 0. Are you getting what I am saying? Here the product of these two brackets is 0. That means either first bracket 0 or the second one is 0. So here either 2x minus 3 equal to 0 or second bracket is 3x plus 1 equal to 0. But if 2x minus 3 equal to 0, then what will be the value of x here? X is equal to, this minus 3 will be shifted to right hand side, so it will be positive 3, and this 2 is in multiplication of x, so it will be in division. So the very first value of x will be 3 upon 2. Or if 3x plus 1 equal to 0, then 3x is equal to, this plus 1 will be shifted this side, so it will be minus 1, and x equal to minus 1 upon 3. So this is the second value. So here x is having how many values? 2 values. In last video I told you that the number of zeros depends on the degree of the polynomial. So here we are talking about what? Quadratic polynomial, and we know that the degree of quadratic polynomial is what? 2. If degree of quadratic polynomial is 2, that means it has how many zeros? 2 zeros. So these 2 zeros are, one 0 is 3 by 2, another 0 is minus 1 by 3. Yes students, now we got the 2 zeros of this polynomial. So we will consider 2 zeros of px are, first 0 was 3 by 2 and the second 0 was minus 1 by 3. Understood? Now, as we know that zeros of polynomial are always denoted by alpha and beta. So the very first 0 will be alpha, that is alpha is equal to 3 by 2, and the second 0 means beta is equal to how much? Minus 1 by 2. Is it clear? Now the verification. For verification we have to take the, now sum of zeros, there is a formula that is minus b upon a. I explained this formula in the previous video. Have you remembered? Okay. So minus b upon a. What is b? So minus b is coefficient of x, or upon a is coefficient of x square. Understood? Now sum of zeros. Zeros are alpha and beta. So I am writing here alpha plus beta. This is sum of zeros, equal to minus coefficient of x upon coefficient of x square. Clear? Now we have to substitute the values of alpha and beta here. The value of alpha is 3 upon 2 plus the value of beta is minus 1 upon 3 equal to minus coefficient of x. Coefficient of x where? In p of x. Beta p of x is given 6x square minus 7x plus minus 3. So here the coefficient of x. What is the coefficient of x in given polynomial? Beta x is here. So its coefficient will be what? Minus 7. So minus is in formula, and in place of coefficient of x we can substitute minus 7 upon coefficient of x square. So what is the coefficient of x square here? That is 6. So we will put 6 here. Now 3 by 2 plus minus 1 by 3. We will take the LCM. So what is the LCM of 2 and 3? It will be 6. We can just simply calculate this. You know how to calculate how to add the fractional number. So I am taking 6 as LCM. So in the table of 2, 6 will come at which place? 3 is a. So 3 is multiplied in the numerator. 3 is a 9 plus and minus minus, and in the table of 3, 6 will come at which place? Second place. So 3 2s are 6. So 2 is multiplied in 1, that is 2. And this minus into minus, it will be plus. So it will be plus means 7 upon 6. Now 9 minus 2 is 7 upon what? 6 is equal to 7 upon 6. So here LHS is equal to RHS. Hence LHS is equal to RHS. Hence it is verified. Is it clear? So here only the first formula is verified, sum of zeros. But there are two formulae. One is sum of zeros and another is product of zeros. So sum of zeros we have verified here. Now I am taking the second formula, product of zeros. After doing this, we will do the product of zeros. Now the product of zeros. Formula was C upon A. I explained you in the last video. So the product of zeros is the formula is C upon A. What is C? C is the constant term and A coefficient of x square. Now product of zeros, but zeros are what? Alpha and beta. Product means multiplication, so their multiplication will be what? Alpha into beta is equal to constant term upon coefficient of x square. Now we have to substitute the value of alpha and beta as previous case. So alpha is what? 3 upon 2 into beta is what? Minus 1 upon 3 equal to constant term from where? From the given polynomial. So here in this polynomial, what is the constant term? That is minus 3. So we have to put here minus 3 upon coefficient of x square. Coefficient of x square is 6. So we will put here 6. Now two fraction numbers are here and we want to do the multiplication. So what is the rule? Numerator is multiplied by numerator and denominator is multiplied by denominator. So 3 into minus 1, that is minus 3 upon 2 into 3, that is 6, equal to minus 3 upon 6. Again here this value is minus 3 upon 6 and the value of right hand side is also minus 3 upon 6. So LHS and RHS both are equal here. So hence LHS is equal to RHS. So the second formula is also verified. So you have to write here verified. So here the very first part of the first question is completed. Find the zeros of the following quadratic polynomial and verify the relationship between the zeros and coefficient. I hope you are understanding. Now let us take the second example. So what is the second example? X square plus 8x or plus 15. So process will remain same as this. First we will consider the given polynomial as p of x. So this is equal to x square plus 8x or plus 15. So first of all we have to find the zeros of this polynomial. Again this is quadratic polynomial and it is having how many terms? 3 terms. If 3 terms are there, then we will use the method splitting the middle term. So what was the first step there? I told you that first we will multiply the constant term and the coefficient of x square. So what is constant term here? That is 15. Multiply by coefficient of x square. But problem, there is no coefficient of x square. So what we can take? 0? No. If nothing is there, that means 1 will be there. If no coefficient is here, so we can take 1. It will not be 0. Are you getting? So if no number is with x square, so we will consider there is always 1. So the coefficient of x square is what here? 1. Now the product of these two, 15 into 1, we will get 15. Now I told you we will break this product into 2 factors. Now this 15 can, we will break this 15 into 2 numbers. Now what sign will be here? Here we will put the sign of constant term. What is constant term? 15, and its sign is plus. So we will have to put here plus. And the sum of these two numbers must be equal to what? The coefficient of middle term. What is middle term? 8x. So here the coefficient of x is what? 8. So we have to put 8 here. Now the concept is we have to break 15 into 2 factors whose sum gives you 8. So the factors of 15 will be 5 and 3. Check. 5 3s are 15 and the sum of 5 and 3 will give you 8. Then first term will remain same, x square. The name of the method is splitting the middle term. We will split the middle term plus, in place of 8 we can write 5 plus 3. So I will write here 5 plus 3 into x or plus 15. Now in the next step we will multiply x inside the bracket. So it will be x square plus 5x plus 3x plus 15. Now there are 4 terms. So we have to take common from first 2 terms and from last 2 terms. So what is common from these 2 terms? X is common. So if x is common, so x square is here. So what is left? X or plus 5 is left. Now this sign plus we have to write as it is. Now what is common from last 2 terms? This is 3x, this is 15. And we know that 3 and 15, both numbers can be divided by 3. So 3 will be the common. So what is left here? X or plus 15. In a table of 3, 15 will come at which place? 5th place. So 3 5s are 50. I told you in the previous question, okay, these 2 brackets must be same. So here these 2 brackets are same or not? X plus 5 and x plus 5. So if these brackets are same, so it can be common. So x plus 5 is common. So what is left in another bracket? This x and this plus 3. So here factorization is completed. But we have to find the zeros of the polynomial. So for finding the zeros, we have to take px is equal to 0. We have to put px equal to 0. But what is px? Px is x plus 5 and x plus 3. So we have to put here x plus 5 into x plus 3 equal to 0. Here the product of these 2 brackets are 0. So either first bracket 0 or the second bracket is 0. So here either x plus 5 equal to 0 or x plus 3 equal to 0. If x plus 5 equal to 0, then x is equal to what? Minus 5. This plus 5 can be shifted this side, so it will be negative. So x is equal to minus 5. Or if x plus 3 equal to 0, then x is equal to minus 3. Hence, these are the 2 zeros of px. So we can write hence 2 zeros of px are minus 3 and minus 5. So half part of the question is solved here. Any problem? All clear? Okay. Now we have to verify the relationship between the zeros and the coefficients. So verification. Hence we got the zeros of this polynomial are minus 3 and minus 5. So implies that zeros alpha and beta. So first 0 is alpha, that will be minus 3, and the second 0 is beta, so it will be minus 5. So the very first formula we will verify sum of zeros. Formula is minus b upon a. Minus b is what? Coefficient of x. So coefficient of x, or upon a is what? Coefficient of x square. So coefficient of x square. Sum of zeros. Zeros are alpha and beta. So I am writing here alpha plus beta is equal to minus coefficient of x upon coefficient of x square. Substitute the values of alpha and beta as before. So alpha is what? Minus 3 plus beta is what? Minus 5. Minus coefficient of x in polynomial. From where we can get the coefficient of x? From the polynomial. Polynomial was x square plus 8x plus 15. So what is the coefficient of x? That is 8 plus 8 now. So minus and plus, it will be minus 8 upon coefficient of x square. X square is here. What is the coefficient? If no number is there, then it will be 1. So coefficient of x square is 1. Now see, minus 3 plus minus 5 equal to minus 8 upon 1 can be written as minus 8. Now minus 3 and minus 5 gives you minus 8 equal to minus 8. LHS is equal to RHS, hence it is verified. So LHS is equal to RHS, hence it is verified. Here we have verified the formula of sum of zeros. Now the last product of zeros we have to verify it. Now we will take product of zeros. Second formula, product of zeros. Formula is constant term upon coefficient of x square. Now product of zeros are alpha and beta. So product means alpha into beta. Constant term, what is constant term in the polynomial? That is 15 upon coefficient of x square. Coefficient of x square is what? 1. Now we will substitute the values of alpha and beta. Alpha is what? Minus 3 into beta is what? Minus 5 is equal to 15 upon 1 can be written as 15. Now minus 3 into minus 1, minus into minus plus 3 5s are 15 equal to 15. Again LHS is equal to RHS, hence it is also verified. So LHS is equal to RHS, hence this is also verified. Now clear? Are you enjoying this? Okay. Now let us take the third example. X square minus 17. How can we find out the zeros of the polynomial and how we will verify the relationship between the zeros and the coefficient for this polynomial? That is x square minus 17. Process will remain same as these first two parts. So first we will consider the given polynomial as px. So px is equal to, polynomial was given x square minus 17, but there is some difference between first two parts and the last part. In first two parts there were 3 terms, but here only 2 terms are here. No matter, in all the 3 parts they are the quadratic polynomial, but the number of terms, in the first part there are 3 terms, in the second part again there are 3 terms, but in this part there are 2 terms. So we cannot use splitting the middle term here. So how can we factorize it? How can we find out the zeros? This is also very simple. What we can do, see, px is equal to, x square is here, it will remain same, minus, because 17 is not a perfect square number. So can we write 17 as this, under root 17 square? Can we write in this manner? Yes or not? Because we know that the square of square root gives you only 17. Means the square of square root 17, you will get 17 only. We can write in this manner? Okay. Now, if this is x square and root 17 is y, so it will be y square. So there is an identity, you know, x square minus y square. So what is the identity? That is x plus y, and in next bracket it is x minus y. Have you remembered this identity? We have already studied in grade 9th, second chapter, polynomial. Identity a plus b whole square, a minus b whole square, and the third identity was a square minus b square. So it was a plus b and a minus b. Same identity we will use here. This is a square minus b square. So px is equal to what was the identity? X plus y and x plus y, x minus y. So what is x? X is x here, plus y. Y is under root 17 and x minus y. So x minus y is under root 17. Now our factorization is done here. Now we have to find zeros. So we have to write for finding the zeros, we have to take px equal to 0. So what is px? X plus under root 17 and x minus under root 17 equal to 0. Here either this bracket 0 or this is 0. So if x plus under root 17 equal to 0, then the value of x will be minus under root 17 or not, or x minus root 17 is 0. So if this is 0, then from here we can get x is equal to positive under root 17. So hence the two zeros of this polynomial are minus under root 17 and positive root 17. So hence two zeros are positive root 17 or negative root 17. So these are two zeros of this polynomial. Now we have to verify the relationship between the zeros and the coefficient. So after doing this, we will verify the relationship. So the two zeros of this polynomial are minus root 17 and positive root 17. So implies that first 0 is alpha, so it will be minus under root 17, and second 0 is beta, so it will be under root 17. The very first relationship is sum of zeros. Sum of zeros is minus coefficient of x upon coefficient of x square. Sum of zeros, as before, alpha plus beta is equal to minus coefficient of x. What is coefficient of x here? Beta, x square is here, 17 is here. So there is a term of x square and this is a constant term. So there is no term of x. If there is no term of x in this polynomial, so the coefficient of x will be 0. Are you getting? Coefficient of x will be 0. Why? Because the term of x is not present in this given polynomial. If the term is not present, then its coefficient will be 0. So minus coefficient of x will be 0. And coefficient of x square. X square is present. But its coefficient will be, if nothing is there, then what will be the coefficient? That is 1. So we will put 1. Alpha. Alpha is minus root 17 plus beta. Beta is under root 17 is equal to minus 0 upon 1. 0 upon 1 gives you 0 and minus 0. You know, 0 is neither positive nor negative. So if minus sign is there, so we will remove this because 0 is neither positive nor negative. So it will simply 0. Now see, this is root 17, this is positive and this root 17 is negative. Both are equal but with opposite sign, so they can be cancelled. So negative root 17 and positive root 17 gives you 0, equal to 0. LHS is equal to RHS, hence it is verified. So LHS is equal to RHS, so the very first relation is verified. Now the second relation is product of zeros. So let's see the product of zeros. How can we verify that relationship? So the second part is product of zeros. Formula is constant term upon coefficient of x square. Product of zeros. Zeros are alpha and beta. So their product will be alpha into beta. And the constant term is what? That is minus 17 upon coefficient of x square. Nothing is here. So if nothing is here, that means coefficient of x square will be 1. The value of alpha is minus root 17 into the value of beta is positive root 17 is equal to minus 17 upon 1. Beta 17 upon 1, we can write simply minus 17. Okay. Under root 17 into under root 17. That is under root 17 square. Or if square is there and square root is also there, so square root will be removed or not? So it will be the product of root 17 and root 17 will give you 17 only. So minus 17 is equal to minus 17. Again, LHS is equal to RHS. LHS is equal to RHS. Hence it is verified. Clear? Understood? Okay students, now I am going to bind up this video. So after this video, I will provide you the worksheet. You have to complete the worksheet and you have to complete both the exercises, exercise 2.1 and exercise 2.2. Both the exercises are based on today's lecture. Understood? And the remaining topics we will discuss in next video. We will meet again after a break.